So the good thing is that I feel like these lessons build on each other. So it's just a continuation of what we've already did, talking about vertex, domain, range, talking about transformations, okay? So hopefully you recognize, if I unzoom this here, or focus it, this represents the parent function, okay? We talked about this a bunch where if you look down at the next one, this is the parent function because there aren't any numbers to the left or the right around it, okay? So let's start here. If we're dealing with the parent function, we know what the vertex is. The vertex, let me get a pen here, will be 0, 0. So if we know the vertex is 0, 0, and we know it makes a U, that means my vertex is kind of important. That should go in the middle. Too smaller, too bigger. Now, did I have to pick these points? No, I could have picked -10 and -20. But then I'd probably want to pick +10 and +20 so it matches up. Okay? Now I plug it in. I'd rather pick positives than negatives, and I know these two should be the same and these two should be the same. 1 squared is 1, 2 squared is 4. So it should match. I'll graph it here. Let me get my glasses on. Sorry about that. Okay, so 0, 0, -1, 1, and then 2, 4. Okay, so that's my parent. So what I'll do is I'll put that in green so you know that that's what the parent is. Goes for the vertex, okay? The axis is the axis of symmetry. The axis of symmetry represents the point where when you cut it in half, it is perfectly symmetrical. It's an axis because it's not actually part of the graph. It's the part where when I cut it in half, it will be the same on both sides, okay? Now, not all graphs have that. If I gave you this graph, there is no axis of symmetry. If I go like this and I fold it in half, this won't match that. So this does not have an axis of symmetry. Okay? All right. So the axis of symmetry is always based on the x value. So it would be x equals 0. So it's based on the x value. And you'll notice a lot of times I put my x's in pink. Okay? My domain. Domain means everything to the right and everything to the left. All real numbers. -infinity, +infinity. My range represents everything up and everything down. It's only going up. It's going up to +infinity. Where does it start at? 0. So 0 is my smallest value to +infinity, or y is greater than or equal to 0. You're seeing that we do a lot of domain and range. You're seeing we do a lot of transformations. Okay? Standard form just means write it as it is. So f of x equals x squared. The parent function is always in standard form. Okay? Now they want you to graph the next one. Let me zoom out a little bit. And this time I go, okay, well, what's the vertex? If you remember, it's always of what's opposite there and the y value here. Okay, you should start feeling more comfortable with this. This shouldn't feel like you have no idea what's happening. Okay? So 4, 1, I'll put that in the middle. 3, 2, 5, 6. What should be true about these two? What should be true about these two? So now when I'm going to plug it in, do you think I'm going to pick 3 or 5? I'm going to pick 5 because, now could I pick 3? Yeah. But I'm going to pick 5 because 5 minus 4 is 1. 3 minus 4 is -1. I don't like negatives. So 5 minus 4 is 1, squared is 1, plus 1 is 2. 6 minus 4 is 2, squared is 4, plus 1 is 5. Okay, and if you're like, I don't believe you, Ms. Rifkin, then you plug in the one that's matching and see if you get the same thing. Now the axis of symmetry, let me graph this really quickly. So 2, 5, oh man, it's not going to be as pretty as I want it to be. So 2, 5, 3, 2, 4, 1, 5, 2, there. Okay, so here is my new one. I guess I'll go like this, so you can see how it's transformed. What do we notice? Hey, we notice that a horizontal translation 4 to the right. So horizontal translation 4 to the right. You can't write that if it's your quiz. You have to write it out. And then I notice it went up 1. A vertical translation 1 up. Okay? So now that means this axis of symmetry is right here. Right through the x value of the vertex. Okay, what's the domain of all parabolas? All real numbers. negative infinity to positive infinity. Of course I want you to memorize it, but I want you to understand it. Otherwise it's just something you're going to brain dump. Everything to the right, everything to the left. Okay? Let me address this. This is all based on the y value of your vertex. Okay? So that means the range is all based on the y value of your vertex, whether you do it in set notation or interval notation. Doesn't matter. Know how to do both. Standard form. Now this is not in standard form. This is in vertex form. So I'm going to have to put it in standard form. So I don't really have much space. I guess I'll just do it here. So what I would do if I was going to put this in standard form, let me kind of go like that. Minus 4 squared plus 1. So the first thing I'm going to do is I'm going to multiply this out. If I multiply this out, I'm boxing it out. And if you don't want to box it out, that's okay. You can also write it 2 times. X squared minus 4x, 16. So that's x squared minus 8x plus 16. And then plus 1. So don't forget about that plus 1 that you're bringing back down there. And now I get x squared minus 8x plus 17. So in standard form, it is g of x equals x squared minus 8x plus 17. Okay? Now I want to point out, if you want to, if you don't want to box it out, instead of going like this, you can go, and some teachers call it FOIL. F for first, outer, inner, last. I still get x squared minus 8x plus 16. Some of you might have not have been taught that, so don't worry about it. But yeah, I need to get a trinomial. That means there should be 3 terms, not 2. Okay? Now let's go to the next one. I'm going to do the exact same thing. The only difference is, instead of it being a u, what is it? A v. So, if it's my parent function, what's the vertex? 0, 0. Now what I need you to remember about absolute value is it means the answers are always positive. The absolute value of a number means what is the value of that number. If I say 3, what is the value of that number? 3. Okay, I got 3 fingers. I bet you would agree. If I go like this and I say, what is the absolute value of that number? Some of you would say -3. No, it isn't. The value of the number is 3, but you take away 3 fingers. So the absolute value of -3 is 3, because that's the value of the number. Okay? All right. We know the vertex. -1, 1, -2, 1, 2. The absolute value of a positive number is still positive, it matches. The absolute value of a positive number is still positive, it matches. 0, 0. Do it in green so you can see it's the parent. Always the vertex is 0, 0. That means it's going to have a similar axis of symmetry. X equals 0, which is the x value of the vertex. Domain, it's the same thing as the u. All real numbers, -infinity, positive infinity. Range, y is greater than or equal to 0. It's the y value. You should see how the v and the u are very similar. This is really a good test in, do you actually understand domain and range, or are you memorizing? Okay? And if you're memorizing, fine. But don't forget it, because it's going to come up all year. Okay? In standard form, that's the way it is. Okay? So, now let's go to the transformed function. Remember how in the previous one, let me move this up a little bit because I think my head's in the way. The x value of the vertex was here. Always do the opposite. There's nothing in there, so that's 0. And then the y value is what's on the outside. What's on the outside? -6. Which means now, if this meant vertical translation 1 up, this means vertical translation 6 down. But what about the 1/2? Well, the 1/2 doesn't affect my vertex, but it does affect my transformations. Okay, so that means that would be a vertical compression by a factor of 1/2. Okay, so if you vertically compress me, what you're doing now is you're smushing me, which means I'm getting wider. If I weigh 300 pounds and you smush me vertically, I'm still going to weigh 300 pounds. So now if I'm shorter, I feel fatter. I look wider. Okay? And remember, those words aren't bad. Those words aren't good. They're just words to describe something. All right, my vertex, 0, -6. My axis of symmetry is based on the x value of the vertex. Nothing changes. My domain, all real numbers. I don't need to draw a picture of it. I will. But I don't need to draw a picture because I know the v and the u have the same type of behavior. They're just shaped a little bit differently. I also know that the range is based on the y value. What's the y value? -6. And then now, -6, positive infinity. Now, in standard form, you cannot distribute the 1/2 in there. You cannot do that. So standard form for this case and vertex form are the exact same thing. You cannot simplify it all. You can only change, if you can change it, then there's a difference between vertex form and standard form. So if you have parentheses, that means you can change it because you can multiply. All right, -1, actually, I'm not going to use -1. I'm going to use -2, and I'm going to use -4. Why am I doing that? Because if I use 1, half of 1 is a half minus 6. And you're like, but I can do it. It's -5.5. I can barely graph one that crisscrosses. I don't need to deal with fractions. The absolute value of 2, 2. Half of 2, 1. -6, -5. 4. The absolute value of 4 is 4. Half of 4 is 2. -6 is -4. And now I graph it, -2, -5, in no particular order. I don't know why, that's what I picked. 0, -6, -4, -4. And then I think it's the same thing here. Oops, why am I off? Okay, do you notice how it looks wider than the original one? Hopefully you notice that. Okay, now we got another one, the square root. Do you remember the shape? Half u. So what's the vertex in the parent function? 0, 0. Okay, so this is my parent. Now, am I going to pick -1 this time? Well, no, I'm not going to pick it because these won't match. There's no symmetry. It just only goes to the right. If you look at this one, it goes to the right and it goes to the left and it's symmetrical. It goes to the right, it goes to the left, it's symmetrical. Okay? In this case, it is not symmetrical, so I have to pick numbers. So maybe the 0, 0 has to actually go up there because that is my vertex. I'll wipe that out later. What number do you think I'm going to pick? Do you think I'm going to pick a negative number? No, I can't take the square root of a negative number. And some of you go, yes, you can. I can take the square root of -4. It's 2i. Yes, I can simplify that. But that is imaginary. I cannot graph something imaginary on a real graph. I can simplify something imaginary, but I can't graph it in real time. So I will pick 1, and the square root of 1 is 1. Do you think I'm going to pick 2? No, I can't take the square root of 2. And some of you, yes, you can. Your calculator can. Yeah, but it's a decimal. It's not pretty. So I'm going to pick 4. The square root of 4 is 2. Next number I'm going to pick, 9. The square root of 9, 3. What number do you think I'm going to pick next? 16, 4. What's my vertex? 0, 0. My axis of symmetry, is there a symmetrical place? No. Is there a domain? Yes, there is. Okay. If I was to graph this 0, 0, 1, 1, 2, 4, 9, 3. Wait, I think I'm off. Wait, that's 4, 2. Just kidding. 4, 2, 9, 3. I knew that didn't seem right. It's kind of going like that. Okay. So I look, it starts here and goes to the right. 0x is greater than or equal to 0. 0, positive infinity. The range means everything up and everything down. Well, it's only going up, and it starts at 0. 0, positive infinity. If you're struggling on domain and range, text me, we'll figure it out. Standard form, same thing because you cannot simplify. I'll finish the next one in the next video.